Hello and welcome back. This is Alan, and this is the next step. This lesson corresponds with the next step in our example of building a program. And, our program is to be a keyboard filter that would convert what we type into upper lowercase. Just an example. And the next step in our example, according to the outline I have, according with the outline, was to look at using the DOS method of reading from the keyboard. Okay, we've already done this bit. Now, we gave up on this bit, and now we're on this bit. Backwards. Okay. Now, DOS is the operating system in this environment, in our debug environment, and in fact is another example of one of those abstraction layers I was talking about. I made a picture here to help us understand what's going on. Here's the real world that you wake up in the morning, you brush your teeth or whatever. In the real world there are physical things like keyboards and so on. And what BIOS does is it takes away some of the complexity of the real world and hides it so that DOS doesn't have to worry about what the particular details of the devices connected to our system. Now the DOS here, as I said, is another abstraction layer. And its job is essentially to hide the BIOS from us. We're the programmer. I don't mean that hide in the sense that it's gone or we can't use it. We can, as you saw, we can access the BIOS. We can read directly from the keyboard. So it's not that it's trying to hide access. Its purpose is to help us and allow us to not have to go directly to the keyboard to find out what someone typed. And hide something. That's the question. What is it hiding? In terms of the keyboard, anyway. What is it? What is the intention here? What is it trying to hide from us? And I wrote down 3 questions. Now, since it's an abstraction layer, this operating system thing, Windows is another example of an operating system. My question would be, and so should yours, if you think about it, what is the intention of this abstraction? What's not what is it intended for, but what is the end result going to be? What is it going to look like? What's their goal? Another question you could ask is how can we abstract away something that's already been abstracted away? The keyboard now has vanished and turned into a concept, and now we're taking that concept and turning it into another concept. How is that possible? Well, the answer to that is very easy. A concept is just like any other thing. It's certainly something you can find. You can find another way to view. like anything, there's always another way to look at something. So there's nothing different about this kind of abstraction as opposed to this kind of abstraction. Here there's some details that this guy doesn't want to know about, and here there are some details that we don't want to know about. So there's no logical difference really between abstracting a real thing away and abstracting an abstract thing away. And the last question, why? Well, the why bit is something that we'll get to and will become obvious as we make the program. But I guess at the simplest level, in order to answer question 3, we need to sort of answer question 1. So, what is that abstraction? And before answering question 1, I'll try not to take too much time. I'm just going to tell you that I went to look through what I happen to know is the interface to the DOS operating system, interrupt 21, called the interrupt table. And I thought, at a hunch, that if I look through that page that I have on interrupt 21, and I search for the word keyboard, then I'm not going to find anything to do with keyboard. That is, whatever's going on here, the concept of keyboard will be gone by the time we get here. There won't be any more keyboards in the universe at this point. So I went through looking through the list, and I looked through the list, and I did actually find 10 matches for the word keyboard, which I was surprised. I was pretty sure I wasn't going to see anything to do with keyboards. It turns out, actually, the ones that I did find really had nothing to do with DOS. One is a networking thing, Lantastic, an add-on. Another is a double DOS, which in the old days was another add-on you could put with DOS, which is DOS, by the way, is not a multitasking environment. Only one program runs at a time, ever. And this extension allowed people to run more than one program at a time. And that particular add-on happened to use the same interrupt as DOS for some of its keyboard functions. So again, nothing to do with DOS. And the last one, this is a whole other operating system, but nothing to do with DOS. It's true that the new world, our new Twilight Zone, has no keyboards. So now that we've entered this new world, we can no longer ask this question. How do we read from the keyboard? If you went to it's like that's why I thought about the Twilight Zone, where there's always this guy that wakes up from a dream or something, and the world doesn't make sense anymore. Everything's upside down, and nobody can understand its questions anymore. And like he might ask, how can I read from a keyboard? And the people around him look confused with their keyboard. What do you mean keyboard? There are no keyboards. That's essentially what happens at this point. We're in the Twilight Zone, and the new universe does not contain keyboards anymore. It has a new abstraction. Everything in the new world is called a file. So this is the answer to your first question. The intention is to turn everything into a new type of thing called a file. And the analog in the real world, I guess, would be paper files, things in filing cabinets. Or whatever. I don't know if you have a filing cabinet, but there used to be a time when people had put all of their information on paper, and they had to store the information somewhere, and it's called a filing cabinet. And probably within the next 10-15 years, this word, filing cabinet, this word, or this idea won't exist. Now, maybe it doesn't exist in your world, but in my world, like when I grew up, there were such things as filing cabinets. Okay, now what's the reason? Going to the last question. The reason for this abstraction is to hide the thing that's trying to be hidden, and for good reason, is the source and the destination of data. That is, if we're writing a program, and we're reading in information and writing out information, if it's possible that it can be in such a way that we don't know exactly where things are coming from and where they're going, then we can sort of just fiddle outside with these things, and we don't have to change our program in order to make it do other operations. One of them is I/O redirection, like you've seen with the arrows and the pipes and so on. These things. That stuff that you type at the command line redirects output from one program and turns that into the input of another program, and then we can again turn that into then that program outputs something, and we could put that into another thing, and so on and so forth. So that's great. That allows us to easily change the flow of data. And that gives us in turn transparency, what I've called transparency in network communications. We don't need anymore to worry about the details of network implementations. When they first came out with networks, they used to have a team of people whose sole job was to maintain the network in the office, and it was a big, complicated mess. But nowadays, the network and the files on the network, and the computers on the network, just look like any other resource. It looks like a network resource looks to me like another folder in my system, and I can go through and open files and read them and close them and so on. I don't have to form a network packet and find an address and all this crazy stuff. So that's that. And also the internet was coming along in that time, at that time, and this was thought to be definitely going to be necessary to enable the same kind of transparency in accessing the internet. Okay, now I wasted a lot of time. I want to just get to actually doing it. So let's just go and do it first. Whoops. This one. Alright. First, reading a key. I'll get back to that thing once more. Reading a key. I told you there was nothing but files anymore. So how do we read a key? Well, we gotta look at a file. And there are 3 files, these ones in particular, that may or may not have to do with the keyboard. We don't know. But sometimes they are. And if there's going to be anything coming from a keyboard, it's going to come from this file, stdin. So I went through the table for my int 21, for my int 21. And here it is. Function 1, read character from standard input without echo. That sounds like what we want, because we might want to change the case. Easy enough. Put 1 into the A high, the high byte of the AX register. Call int 21, and the character returns an A low. What could be easier? Let's try it. Move the A high 1, int 21. Oops. That's it. Well, maybe I'll add a jump. Okay. Now we've got a 6-byte program. First, let's set this to trace through. Okay, I should put that in for that. Oops. Trace through. Okay. Put 1 into A high. Done. Int 21. I must proceed over this long operation. It's waiting for me to type a key. I'm going to select a small letter A. The answer to that should be 61. There it is. 61. So that part is done. That's it for that part. Okay. Now if I type go on this, oh sorry, that was with echo, wasn't it? Because I got an echo here. See that? That's the little A I typed. Let's check again. There is a without. Yeah. I'm half asleep here. With echo. The one we want is without echo. So in fact, that's not the one we want, but we can still play with it. Let's go there. No. Don't go hungry. Well, that's a program already in itself. If I type go here and start typing, you may have noticed something there. I was pressing backspace and those characters didn't disappear. So that's an interesting problem. Why did that happen? Okay, so here I am. I can type. This is running through that program. It's going through that loop. These here characters are from the echo. We didn't do that. Somebody else did. And actually, we don't want this bit. But it's there, and then we have to deal with it eventually. Now, how do I get out of this loop? I think Control-C will take me out. Yeah, okay. Alright, fair enough. That works. Let me just try something else. Let me run this program again. And type in a few characters. I'm going to press enter and see what happens. Okay. Now you notice here that the cursor moved from here to here. That's called a carriage return. What we would like is for it not to just move from here to here, but maybe scroll the page up, which is called line feed. We don't have that. So we could actually fix this up a little bit, make it a little bit better by adding this part. Instead of jumping here, actually, let me not do that. Let's first find out what we're going to get. Oh, I'm going to do that. Okay, I'm going to press the enter. Now the enter gave us a D, and that means that is in fact the character for carriage return. But what we want is we do want to bring the cursor back, but we also want a line feed. So I'd like to add to this. If we read this one, I'd like to add a line feed. The line feed character happens to be A. You can look it up. So I'm going to start at 104, and I put a comparison here. I'm going to compare what we got to D, and in that case we would like to add additionally a line feed. So I read too much through the documents, and they said that you should always let the expected case be the one that falls through. So usually we don't get a D. So that's the unusual case. So if these things are equal, jump is equal, jump is Z. Okay. We're allowed to do that too. If A low is equal to D, that's unusual, so we should jump. Where do we want to jump to? I don't know. So I'm just going to put 106 for now. That does nothing. And that leaves us at 108. Now at 108, 108 is the normal case where it wasn't a carriage return, and all we got to do here is go back to 100. Now we can see where this guy wants to wind up. We're going to go to 10A. So let me fix that. Okay. What we got so far. Read a character, check if it's a return, and if it is a return, go to 108 where we have garbage, otherwise continue. So in the garbage, we have to find out now how to print something out. So let's see what we've got. Test, let's say DOS test, and we need to save this off. How many we got so far? A. B is clear, we're ready to write. Okay, let's save if we get back to it. Okay, now I got that in the list here. Writing a character. That is function 2. So we put A high equal to 2, D low, the character we want to write. And there's some additional information that we could care less about. If it works, we're happy. Maybe we might need that information later. Who knows? And we save this thing out to DOS test. Is it still there? Yeah. Okay. So at 108, we need to use that function to print out the A character. And that told us to put into AFI2 below character we want to write. Okay. Trust me, that's the one. And call off 821. Okay, now at this point we will have printed a line feed. So we're done with that bit. So we can go back to resuming the loop. Okay. Now how many bytes do we got? I want to save this one off too. We have the last one. We have 12 bytes. Now I can type go from here. Might as well. Sounds perfect. So I think, well, I can't help the bit that it went back, but if it didn't go back, it would start typing at this one, which is never good. That's not what people expect. So we can do spaces and so on. We still can't do backspace. Those are backspace. The arrow keys do weirdo things, so that's a bit of a problem. And the last thing, how do I get out in this loop? The only way out is Control-C. That's okay for now. Okay, so now we have a program that does part of what we want. We can read in the keys. We can make line feeds and carriage returns, print to the screen, and that's great. Now what else do we need in here? Well, for one thing, I don't know how long this is so far, is we need to be able to quit. We got no way to get out of this thing. I'm going to pause here. I'm going to hit pause and see how much time I've wasted. It's too long, I'll quit. If not, I'll do that as quickly as possible. Actually, just a minute. Okay, it looks like I've used 28 minutes. So that's too much. But before I go, I'm going to just outline given what we have, how can we just quickly add in a way to get out of this program without Control-C? And I'm just going to tell you right now that there is a special character that tells us when we hit the end of the file, as they say, end of file character. So what we need to do is add to all this stuff and another test to see, just like this one, if there's an end of file character. And when we find that end of file character, we should quit. And that's what I'll put in the next one. And the tricky bit is this. We're kind of blocked in here, there's no space to put that extra comparison in. So we can either start from scratch, or we can find a way to somehow squeeze that extra test in there. I'm going to squeeze the test in just for fun instead of starting it from scratch. Okay, see you next time.